Okay, in this section, so let us do the example here. We've done this yesterday, right? Did we draw it yet? Interesting. Where is it? Oh, that was an ellipse. But now this is a different things. Okay. Okay, the same story. Let us do this example together. Now, this is a hyperbola, right? Because in front of the y terms here, there's a negative sign. It's not an ellipse, right? That is the only difference between these two. So the same story. Let us write it in forms of hyperbola. So the same process. We will divide both sides by 144, right? It becomes, what is it? It will be x squared divided by 16 or 4 squared, right? And y squared, sorry? Say it again, please. I'm so sorry, I still don't get that.
Do you think this problem is going to take longer than the page to work out?
Oh, I'm not sure, just maybe, yeah. So let us write it in this standard form, right, of a hyperbola. Here, then it will be 3 squared. Okay, now so let us draw it a little bit. Sketch the graph. So when y is equal to 0, x will be plus or minus 4, right? So it should be somewhere here. So it means that the hyperbola, the foci will be on the x coordinate here, right? We know that. And these 2 points belong to the curves. Okay, very good. And there's no y-intercepts. So it should be like this. You agree? But we're not clear for now. And the foci will be somewhere here. Let us just guess. F2 is here. F1 is here, right? So in this case, what are A and B? Okay, A is 4, then B is 3, right? Therefore, we have the formula that C squared will be, right? And it is 25, right? Therefore, C will be 5, right? Okay. It means that the foci will be F1 at what is it? Yes, right here and right here, right? Okay, very good. What else do we need to know about the hyperbola? Say it again, please. Asymptotes, very good. So the foci we know is already C, and the asymptotes here. Right, which is the linear lines, which is this guy and this guy, right? Not a good draw. And the first one, it will be y is equal to b over a x here, right? So we see that b is 3 right here. It means it should be somewhere here, right? 3 and 3, negative 3 here. So now in order to factor this, let us draw a rectangle. So it will be this rectangle. Right, let us find it first. Okay. Then the first asymptotes will be b over a x, which is 3 over 4x, right? And these linear lines go through the origin at 0. So the lines should be like this. And the other lines, right? Y will be, which is negative 3 over 4x here, right? The same slope, but the slope is negative of this. Therefore, it should be this guy, okay? Now, the hyperbola here, it should, when x becomes large, right? It will come closer and closer to the asymptotes here. It will be like this. Okay. That's it, right? That is how we can draw a hyperbola. And remember the ellipse, the previous example here, the ellipse, it will be the ellipse inside this rectangle, right? That is the only difference. Okay, is it clear? So we play with ellipse, parabola, and hyperbola. Now, the next things will be shifted, conics. It means that the origin, this point will be shifted somewhere. Before doing that, let us take a look at this circle. So it has the radius 1, this is a circle in 2D, and that this is an ellipse in special case, right? Where the two forces Okay, becomes the center here. And this center, if the circle, if it is shifted to here, for example, first, what is the equation of this circle? Equal to 1, right? And this here, it has the same radius here. And what is the equation of this circle? Right? Because here, the center here is at C 2, 1, right? If we plug it into this equation, so when y is equal to 1, it means that, look at this line. When y is equal to 1, this term will disappear, right? Then x here, if x is 3, then it's satisfying this equation, right? It means that we have this point. And when x is -1, here is 1, then we have the same, it's satisfying this equation. Therefore, okay. In general, you can play with this graph, x squared, right? And x -2 squared, which is the graph of this, but it is shifted to the right, right? The same, sorry? Yeah, anyway. So if it is shifted to the right of the x coordinate, then it is subtract 2, or you see that at 2, it will be at the center. Here, it will be shifted up to, and the center here is at 1. The same story in general. If the conics here, the standard equation of the conics here in the equations 1 to 8, replacing x by x minus h and y by y minus k, the same story will happen, right? For example, let us do this one. You understand it better. Now, find the equation of the ellipse with the forces 2, -2. Let us draw it. Suppose 2 is right here, -2. 2, -2 is this point, right? And the point 4, -2 will be this point. The vertices will be 1, -2. 1, -2 is this point, and 5, -2 here, right? Bless you. Okay, this is our ellipse. And remember, the ellipse, we don't know how it looks like, but it will be somehow similar. It has this shape. It's not a very good ellipse, but imagine, okay? This is the two forces, F1, F2, right? Imagine that y prime, the original axis will be x prime and y prime here, right? So in the x primes and y prime coordinate, so we know that this is c in that coordinate and negative c in this coordinate, right? And the same story, what is the value of a? Negative a here, right? In the red coordinate, what is the value of c? We see that the distance from this f1 to f2 will be 2, right? And it is 2c is equal to 2. Therefore, c should be 1. Very good. Here, 2a will be, what is it? 5 minus 1, it means that a will be 2. We're given c and a, right? So can we find b here? And look at this triangle. What is the relation between a, b, and c? This is b, right? And this is c. From this, we know that a squared, because the distance from this point to f1 and from this point to f2 will be 2a. So this is these two triangle are congruent. So b from this point to f2 is equal to from this point to f1. It means that the distance from this to f2 will be a, right? Half of 2a. And Pythagorean theorem tells us that a squared equal to so a and c are given, right? Therefore, we can compute b, right? And what is b? A squared minus c squared, right? We subtract both sides by c squared. So, and finally, what is it? Yes, 4 minus 1 is 3. Very good. So we know that 3, b is square root of 3. It means that the graph of this one, square root of 3 is 1.7 something. It means that the ellipse, in fact, should be somehow like this guy. Okay. And in this coordinate, the equation of this ellipse will be in the x prime coordinate. What is it? The red coordinate. What is the equation of this ellipse? Yeah, divided by 4, right? 2 squared, or this is divided by 4, and y? 3. Very good. This is the equation in the red coordinate, right? So, and the red coordinate, what is the center of this guy? It would be 3, -2, right? So from all these information, we know that it is shifted to the right this much. Okay. Therefore, here, the equation in the origin, in the red, black coordinate should be yes, plus yes, 2, right? Square here divided by 3 and equal to 1, right? Okay. So we factored, we know how it looks like, but when we write it, we should write all these arguments. We have that from the two forces, therefore we have 2c is equal to 2. Then 2a will be this, and we can compute b, right? We should list all these information. Otherwise, the reader cannot understand why you have these numbers. Okay? That's it. Do you have any question? Are we good? It was here. 3 is a square root of 3 squared. And 2 squared gives us 4, right? Okay, let us continue. And how about this one? Sketch this conic. This one is not in a standard forms, right? Therefore, we should write it in the standard forms. Look at this. Let us rewrite all the terms in x, 9, x squared here, negative 72x, right? Minus 4y squared plus 8y. The numbers is 176. Let us write it in the right-hand side. It would be, thank you, negative 176. Okay. Which formula should we use in order to deal with this guy? Before doing this guy and this guy, can we factor it out and make it simpler? Here, right? What is the like term between these two? If we factor 9 out, right? This guy will be x squared minus 8x, right? And this guy, if we factor 4, negative 4 out, inside will be, yeah, be careful with the negative sign here. It's very tricky. And the right-hand side is negative 176. Okay? Remember, a minus b squared will be plus, okay. Look at this guy. This is x squared, right? And something times x here. But number 8 here, can we write it as 2 times 4? Right? The story here is similar. 2, it means that 2 times 1. If we write it this way, what number should we add here to make it a perfect square? 16, right? Or let us write it as 4 squared here, right? Okay. But somehow we add 4 squared, but in front of that, we multiply with 9. It means that we add 9 times 4 squared on the left-hand side. So we should add the same amount on the right-hand side. Do you agree? To make it even. And here, this guy, which number should we add here? One or 1 square, right? Let us write it this way. But remember, in front of that, we add 1 square times 4, right? And in front of that is a negative sign. It means that we subtract 4. We subtract 4 in the left-hand side, so we should subtract 4 in the right-hand side as well. Do you agree? Now they're even. So let us write it down in a simpler form. Therefore, the left-hand side becomes, what is it? 9 times x minus 4, right? Square. And here minus 4 times, what is it? Y minus 1, very good, square. And the right-hand side, use a calculator to compute it. Okay? Negative 144, right? Oh, yeah. I forgot the number 4 here. So it is negative 36. Thank you. So it becomes negative 36. Very good. So now the equation of these conics, we want the right-hand side to be a number 1, right? So what should we do here? Divided by negative 36, right? Very good. And therefore, the right-hand side becomes 1, and the left-hand side becomes 4, right? And let us write it this way. 2 squared and 3 squared. Okay? Are we good now? Good job. So this is, what is it? Hyperbola. Very good. So, and look at this. How can we draw this hyperbola? If this is x, this is y. So we see that when, before doing this, let us graph this guy. Let us graph minus x squared divided by 2 squared plus right? So so you can definitely, okay, here, if in the red coordinate, this is x, this is y. So when x is equal to 0, then the curves will cut the point, what is it? Plus and minus 3, right? You agree? These points belong to the graph, right? Okay. So we have that A here is 3. Then what should we do next? This number is 2, right? Therefore, in the y coordinate, in the x coordinate, the point 2 and -2 here. Okay. Imagine you are drawing the ellipse. We need to figure out the rectangle here. Okay. Then what should we do? We draw the asymptotes, right? The asymptotes will be the line go through the origin here, and we connect these of the rectangle here. This is here, right? And what is the forces? So we know that c squared will be a squared plus b squared. Therefore, c will be, and what is a in this case? Here, right? Therefore, it is 9 plus 4, it is square root of 13. Do you agree? C is square root of 13. It is 3.6 something. It means that it should be this point. This is 4C. Another 4C here. F1, F2. And the graph, when y goes to infinity, it will come closer and closer to the asymptotes here. Okay. Are we good? But this is the graph of the equation here, right? The real coordinate should be this one, x minus 4. It means that the origin here will be shifted to the right of the black coordinate. It means the black coordinate, it should be on the here at -4, right? Should be this guy. This is the y coordinate. And here, the y coordinate here is shifted up 1 unit. So therefore, this is the real coordinate of x and y. You see how it is shifted. This is -4, right? It means that when x is equal to 4, it is the origin. the origin of the black coordinate is right here. And here, do you see it? So at it means that at x is equal to 4, this one will cancel, right? It is shifted to the right. We do backward. Okay. So here in the black coordinate, we subtract 4. It means at 4 of the black coordinate. So if 0 is right here and this point of the black coordinate, it should be. Yeah. I know it's. I'm sorry, it confused you, but this is how we do backward.
No, you're good. I'm still wondering about
Therefore, we should change the numbers here. We should remove this. Okay, this is 4 and this is 1, right? Now in the original coordinate, it should be like this. I know it's confused you, but we do step by step, do backward.
I get what you're doing now. I was confused.
Yeah. Sorry, but are we good now? I think so. Look at this. Maybe, but look at this. Here, it changed the equation. So A and B it changed because they don't want you to memorize many things. So we if the 4C is on the x coordinate, right? Then we denote the number below x would be A, right? But in the other way around, when the 4Cs are on the y coordinate, we denote A as a number below the y here. So that you can simply memorize the number A and B and C, and it helps you not messing up things. Okay? So yeah, that is why in our case here, A is 3, right? Let's review the notes. They changed the number notation of A and B just, but the principle is not changed. And here, this, again, this asymptote here, the slope of this will be, what is it? 3 over 2, right? 3 over 2. This is the slope. Right? So the slope y will be okay, asymptote. And you can go back here. Here, right? A over B, reverse, I mean, the principle is not changed, but the numbers may play different roles. Okay. This is, okay, again, this is the graph of this x squared over a squared minus y squared over b squared is equal to 1. And the forces will be at negative a, 0, and a, 0. And the hyperbola here is a different notation. It is y squared over a squared subtract x squared over b squared. And the rectangle here, you can see, it should be like this. It's not a good draw, but yeah. right? Where A is this guy and the slope is A over B here. Okay, let's review it. Are we good? Sorry it takes too long, but anyway, we finish the section here.